In this topic, we discuss complex fractions, also referred to as complex rational expressions. We begin with a definition. A fraction that contains another fraction in its numerator or denominator or both is called a complex fraction. The following are examples of complex fractions: 9 over 1/3 minus 2/9 and x over 2 plus 1 over y divided by 1 over x squared plus 1 over y squared. Now, at first glance, complex fractions or complex rational expressions look pretty intimidating. But once I show you some steps on how to simplify them, I think you'll find that they're rather easy to work with. Let me make a quick remark. A complex fraction can always be simplified to a single rational expression. The goal in this topic is to discuss the steps we need to take to successfully simplify complex fractions. Let's look at an example. Simplify completely 1 plus 4/3 over 1/2 plus 1/3. To tackle this problem, we really need to look at our complex fraction in parts. First, we'll focus on the numerator and combine the terms in the numerator into a single fraction. Then we'll do the same with the denominator. So let's begin by looking at the numerator. We have 1 plus 4/3. To add these two together, we need to rewrite 1 as 1 over 1, and then change it to have the same denominator as 4/3. That is, we need to multiply numerator and denominator by 3. That gives us 3/3 plus 4/3, which equals 7/3. We now turn our attention to our denominator, 1/2 plus 1/3. Again, we want to add these two fractions together. To do so, we need a least common denominator, which is 6. This gives us that 1/2 plus 1/3 is 3/6 plus 2/6, or simply 5/6. Now that we've simplified numerator and denominator into single fractions, we can rewrite our original complex fraction using only one fraction in the numerator and one fraction in the denominator. The resulting quotient of the two fractions can then be simplified, since we're simply dividing two fractions, which is the same as multiplying by the reciprocal of the bottom fraction. Let's take a look. 1 plus 4/3 we said was equivalent to 7/3, and 1/2 plus 1/3 is equivalent to 5/6. 7/3 divided by 5/6 is the same thing as 7/3 times 6/5, because we're dividing two fractions. One way to look at it, and some people like to look at it this way, is to simply take 7/3 and then divide by 5/6. And when you look at it horizontally, you can see clearly that to divide these two fractions, you have to invert and multiply. So you get 7/3 times 6/5. You can cancel first or multiply straight across. If you cancel, you can see 3 goes into 6. 2 times, and 2 times 7 is 14. 1 times 5 is 5. And our resulting fraction is 14/5. The procedure for simplifying complex fractions can be summarized as follows. First, simplify the numerator to a single fraction, usually by adding or subtracting two unlike fractions. Second, simplify the denominator to a single fraction. Third, change the resulting division problem into a multiplication problem using the reciprocal of the denominator, that is, the bottom fraction. 4. Multiply and reduce. The main idea of our video, then, is that complex fractions must be simplified in parts. First, we'll focus on the numerator, then the denominator, and finally we'll combine those results by multiplying by the reciprocal of the denominator. This simplifies our complex fractions. We now work several examples. Completely simplify each complex fraction. Example 1a. 14a over b to the 5th c divided by 4b squared a over 5c cubed. The nice thing about this complex fraction is that both the numerator and the denominator are already simplified fractions. So to simplify this complex fraction, all we need to do is divide the numerator by the denominator. Let me show you. Let's take our numerator, 14a over b to the 5th c, and let's divide by our denominator. And I'm going to write the division horizontally instead of vertically. So we're taking 14a over b to the 5th c divided by 4b squared a over 5c cubed. These are equivalent. One's just written vertically as division, and this one is written horizontally as division. But this allows me to see that when I divide two fractions, what do? I flip the second one, invert the second one, and multiply. So let's rewrite our first fraction, 14a over b to the 5th c, and let's invert and multiply by our second fraction. Our second fraction, when inverted, becomes 5c cubed over 4b squared a. So far, so good. Now we simply multiply. And how do we multiply rational expressions? Well, we can either multiply straight across, or we can reduce into prime factors, cancel, and then multiply straight across. I think that's what I'd like to do. I notice that 14 and 4 can be reduced farther. We can rewrite 14 as 2 times 7. So I have in the numerator 2 times 7 times a. And in the bottom, in the denominator, I still have b to the 5th, or 5b's, times c. And on this side, 5 is simply 5, and then a c cubed, 3 c's multiplied together. And the 4 down here can be rewritten as 2 times b squared, 2b's times a. Now, let's cancel things from numerator and denominator that are common. Notice we can cancel one factor of 2 from here and here. We can cancel this common factor of a. We can also cancel some c's. There are 3 c's on the top, and there is 1 c on the bottom. So let's cancel 1 c from each place. 1 c from the bottom leaves just 1. 1 c taken away from the top leaves us with 2 c's multiplied together, or c squared. You can also think of this as using the quotient rule, where you subtract 3 minus 1 and get c to the second power. Now, there's nothing else on the top that can be canceled with the objects on the bottom. And therefore, we're simply going to multiply these factors together straight across. 7 times 1 times 1 times 5 times c squared gives us 35c squared in the numerator. And in the denominator, we have a 2 times 1 times 1 times 1, so that's simply 2 times b to the 5th times b squared. And how do we combine like bases when they're being multiplied? We add the exponents, so that's simply b to the 7th. Therefore, our final answer is that this complex fraction simplifies into 35c squared over 2b to the 7th. Example 1b. Simplify the complex fraction 5x over x squared minus 25 divided by 2x squared over x plus 5 minus x squared over x plus 5. Now this complex fraction is just a little more complicated than the previous one. Notice in the numerator we have a simple fraction. In the denominator we don't. So our first step will be to take the denominator and rewrite it as a simple fraction. Let's rewrite our denominator here off to the side. We have 2x squared over x plus 5 minus x squared over x plus 5. We want to put these two fractions together into a single fraction. The nice thing is the denominators are like denominators. So we don't need to change anything. We simply need to combine the numerator and keep the denominator the same. Our common denominator is x plus 5. And in the numerator we have 2x squared minus 1x squared. But this is also very nice because these are like terms and we can combine those together. 2x squared minus x squared simply gives us x squared in the numerator and x plus 5 in the denominator. Wonderful. We now have a simple fraction that we can replace into our more complex fraction above. So let's rewrite. 5x over x squared minus 25 all divided by, and replace now with the simple fraction, x squared over x plus 5. We now have a simple fraction on the top and the bottom, and so we divide. The top divided by the bottom. And instead of writing it horizontally, I'm going to skip that horizontal division and go straight to multiplication. We're going to take our top fraction, 5x over x squared minus 25, and we're going to divide by the bottom fraction, which is the same thing as inverting the bottom and multiplying. So we're going to multiply by x plus 5 over x squared. Do you see that? So we flip it and multiply, x plus 5 over x squared. That's because we're dividing this one divided by that one. All right, to multiply rational expressions, we first want to cancel things that are common. And in order to cancel things, we first have to factor. So looking at the numerator, 5 times x, well, that's already factored as far as we can go. X squared minus 25, that is a difference of squares, and that factors as x minus 5 times x plus 5. We have x plus 5 in the numerator over here, and here we have x squared, which we can write out as x times x if you like, or just x squared. Now let's cancel common factors. Here we have x plus 5 appearing both in the numerator and in the denominator, so we can cancel that. We also have a factor of x here and 2 factors of x here. We can cancel 1 factor of x from the numerator and 1 factor of x from the denominator, which will leave us with just 1x, or x to the first power, in the denominator. Nothing else will cancel, so now we combine by multiplying straight across. 5 times 1 times 1. In the numerator we have 5. X minus 5 times 1 times x. In the denominator we have x times x minus 5. Our complex fraction has simplified to the single simple fraction 5 over x times x minus 5. If you like, you can multiply out the bottom. That's completely up to you, and rewrite it as 5 over x squared minus 5x. Either answer is acceptable. That completes example 1b.